Hi everybody, this video is talking about tangents to a circle and how to find them. Now, there's a slight reliance on circle theorems, but it's quite a nice one. You don't have to worry about it too much. Notice we've got the tangent line coming along here, and we've got the radius as a sort of a dotted grey line here. Now, the angle between these lines, you may be able to just look at it and see it here. This angle here is a 90-degree angle, right? The angle between a radius and a tangent is always 90 degrees. That's one of the circle theorems. And there's a word for lines that are 90 degrees apart. We can say that they're perpendicular. Okay. Now, we did investigate perpendicular lines within coordinate geometry. Take a moment to see if you can remember the formula. About to write it down. If two lines are perpendicular, then their gradients should multiply to make -1. Okay, and we'll be using that idea very shortly too. Okay, here's the steps that we're going to need to follow to find the equation of a tangent to a circle. The first thing that we're going to do is we're going to find the gradient of the radius. Now that's the dotted line that we've got here. Typically what will happen is we'll know the coordinate of the center of the circle and we'll know the point of tangency over here. So if we know these two coordinates, we can find the gradient of that line. Once we've done that, the gradient of that line, we'll find the perpendicular gradient, which will tell us the gradient of this line. And that's step 2 there. And then we'll just use the straight line formula to finish it off. All right, let's give it a try. Have a look at an example. Let's see what we got. Okay, circle has center 5, 3, and the point 1, 0 is on the circumference. Find the equation of the tangent. Okay, let's go into GeoGebra. Let's get that information down. So it was a point. Center of the circle was 5, 3. 5, 3 is here. And the point 1, 0 was on the edge of the circle. I think that's what it said. Just check that. 5, 3, 1, 0. 5, 3, 1, 0. Okay, fantastic. Let's just change these very quickly so that we can see values instead of numbers. Oh, that's 1, 1. Of course it is. 1, 0. Doesn't like that, does it? Blinking heck. Right. Let's change it over here. There we go. Fantastic. That's better. Okay. So we've got our points. 5, 3, 1, 0. We are going to attempt to find the equation of the tangent, which is this line here. Make it purple. That'll be nice. We're going to try and find the equation of that purple line. GeoGebra rounds the numbers, so we'll be able to get nicer fractional values out. I think this is 4/3, 1.33 recurring. So our answer should have something to do with that. Let's just include the radius line in here as well. That's what we're going to be dealing with first. And let's just change the color of that as well. Let's make it green. Okay, that looks wonderful. All right, let's have a go at this then. The first thing that we're going to need to do, we are going to need to find the gradient of this green dotted line here. We've got the coordinates 5, 3, and 1, 0, and we need to know how steep this line is. Now, the gradient formula is a bit of a throwback as well, isn't it? The gradient of a line is the change of y over the change in x, and you might have written it as y2 minus y1, and that's fine as well. I'm just going to be considering the change of the values. And I'm going to start from the center and I'm going to go down here. So 5 take away 1 for the x values. And 3 take away 0 for the y value. As long as you go consistently from one coordinate to the other, notice I did 5 and 1, 3 and 0. I didn't mix them up. End up with 3 over 4 there for my gradient. So the gradient of this line is 3/4. So I've done step 1. The next step was to consider perpendicular gradients. Now, the perpendicular line formula once again is m1 times m2 minus 1. I've just worked out that one of the gradients is 3/4. I'm thinking, what number would need to go here in order for the two gradients to multiply to make -1? I know it'll need to be negative since this is a positive number. And if I want to cancel out the 3/4, I'm going to need to multiply by the reciprocal. So I'm going to flip this fraction, get 4/3. I'm also going to change the sign of it so that I get a negative there. That should do the trick. Okay, so we talked about a shortcut before. I've basically just applied that shortcut there. So the shortcut was, if it's a fraction, flip it. And whatever the sign is, since this sign is technically positive, change the sign as well, and that'll do it. There we go. So we've got the gradient of this line here. The gradient of this is -4/3. Cool. And one more step. Last step now is do a straight line formula. So I'm going to write down y equals mx plus c. The gradient I've just worked out as -4/3. And the other thing I know about this line, I know a coordinate on there. I know that the point 1, 0 lies on the line, so I can substitute those values into the equation. So I'll replace the x with a 1, and I'll replace the y with 0. See what I get there. Y is going to be 0. And I'll rearrange that equation. I'm running out of space. Uh-oh. Get rid of this here for a moment. I can go. Okay. So let's take this number over here. 4/3 times 1 is just 4/3. Take the 4/3 over so it changes sign. And I get positive 4/3 out as my constant there. Therefore, the entire equation of the line y equals mx plus c, the gradient is -4/3. The intercept is 4/3, and there it is. That's the equation of the line. If you want to multiply it through by 3 to get rid of the fractions, you can. So I could call it 3y is -4x plus 4, or some variation of that. That's okay as well.